and you'll find tiny particles held together by invisible forces. Everything is made up of tiny packets of energy.
Hello, my name is John Newton, and I proved that atoms make up matter. These atoms are indivisible and are fundamental particles.
Greetings, my name is J.J. Thompson, and I discovered that the atom contains charged particles called cathode rays in my famous cathode ray tube experiment.
I am Ernest Rutherford. Through my gold foil experiment, I found that the atom is mostly empty space with a positively charged middle called the nucleus and electrons swarming the outside of the atom. Okay, so our problem is the mass difference between the proton and the atomic mass of the helium atom. The mass of the atom is 4. It has 2 protons with the mass of that equaling 2. It is 2 electrons. The mass not counting because the electron is so minuscule. So they have the problem with the difference of these 2 masses. So what they're trying to figure out is what else is in there that makes it so heavy. Welcome to Baking with the Atom. Today we are going to bake a helium atom. We have the batter as the atom, and then we have our regular red M&Ms as our protons, since they are much more massive than our mini M&Ms, which are our electrons. And so we're going to put 2 of the protons in. 1, 2. And then 2 of the electrons in. And then we're going to mix it all up, and now we have a helium atom. So we're going to bake this and see what they did with the helium atom.
We are balancing the mass of the helium atom. This represents the mass of the 2 protons, and this represents the mass of the 2 electrons.
And this represents our helium atom. The batter is massless. As you can see when we let go, the whole atom is weighing more than the particles that make it up itself.
Oh no! Hello old chaps. My name is James Chadwick, and I discovered a neutrally charged particle called the neutron. The neutron is about the same mass as a proton, as you have seen in the cupcake video shown earlier. I discovered this particle in my beryllium experiment that you will soon see later.
The nucleus of the helium is a massive equivalent to gold. And scientists already know that there are 2 protons inside of the nucleus. But there was a mass difference of 2, and similar
they discovered the neutrons make up the rest of the mass, our green M&Ms. So we put 2 in to make up the actual mass of the helium atom. And there we have it.
Hello. We are once again balancing the helium atom. The red represents the 2 protons. The blue represents the 2 electrons. And the green represents the 2 neutrons.
And now we have the helium atom. And it's balanced because all the particles equal the mass of the helium.
Ta-da! In my experiment, we will take a beryllium atom, which has 4 protons, but it has a mass of 9. Thus, there are 5 unknowns. In order to find out what these unknowns are, I will take an alpha particle and I will shoot it at the beryllium atom, and whatever comes out, I'm going to send that through a positively charged, between a positively charged plate and a negatively charged plate. Let's begin. And this is my experiment. These balls will represent the alpha particles, which I will launch at the nucleus. Inside the nucleus, we have Chloe and Coco as the unknowns, and Ryan as the protons. This positively marked hole will be the positively charged plate. And the negatively charged hole will be the negatively charged plate. We will see what our unknowns do when they go between these 2 plates. If they reflect away from the negative towards the positive, then they will have a negative charge. If they reflect away from the positive and go to the negative, they will have a positive charge. Let us begin. Alas, they didn't move towards either one of the poles. They are neutrally charged. Thus, I shall name them the neutrons.
So now we have a clear picture of where everything is inside of an atom. The protons and the neutrons are on the inside, and the electrons are on the outside. Also, neutrons are necessary to be in the nucleus because they hold the nucleus together. Without the neutrons, the protons inside would repel each other and they would go flying apart. So, here you have it.
Physicists found that the neutron made an ideal bullet for bombarding other nuclei because it had no charge.
The neutron plays a very important role in the chain reaction needed for nuclear weapons. Thus, the neutron played a major part in developing the atomic bomb used in the World War II bombing of Hiroshima and Nagasaki.
In neutron scattering experiments, materials are exposed to intense beams of neutrons inside specialized instruments at large research centers. The images that are made are used to reveal the molecular structure inside the material, which can be directly linked to the physical and chemical property experienced in the everyday world.